Hello and welcome, ladies and gentlemen. And many of you may think, real analysis is so extremely boring. And you may have an idea. Complex numbers are basically like real numbers. But more. And then an incredible idea may descend upon you. This is complex analysis. And hopefully we will have a course on it by the end of next year. And so, basically, I'd like to create this course because, in my opinion, this is an absurdly fascinating subject to study. And most of the things that I will teach you will depend on this very fascinating book. And I will try to introduce new examples, some visualizations, and hopefully a lot of new information in addition to the contents of this book. So, we will cover a bunch of topics. So, let me write them down, and then we will talk about what they will bear with themselves. So the first one will be the basics of complex numbers. In here we will talk about their properties, their trigonometric and exponential form, and stuff like that. The second topic is mainly some complex topology. We will introduce some domains, simply connected, what this property means, and a bunch of other properties of complex sets. Then we will move on to some analysis shenanigans, aka derivatives. So we'll talk about the definition of analytic functions and complex derivatives, there as well as some properties. Next we will move on to some conformal mappings, and I think they can be included in the topic of complex derivatives. And then we will talk about some elementary functions, such as trigonometric functions, exponential, etc. And we will reintroduce them with a complex background. So they will be complex functions of complex variables. Next we will learn how to integrate complex functions. Okay, we will talk about antiderivatives, we will introduce them. So, integration. After integrating, what do we do? That is correct, we introduce residues. So, after the integrals, we will talk about some complex residues of our function, some logarithmic residues, and how they correspond to the zeros and poles of our analytic functions. So, residues. The next topic would be analytic continuations. So we will talk about various branches of our functions and how they can be continued, how we cut them, and we will introduce univalent functions, etc. So, complex analytic continuations. And the last topic will be more topology. So, after talking about stuff like that, as well as Riemann surfaces, by the way, we will return to the topic of topology. We will introduce the notion of isomorphic functions, automorphic functions, as in as a complex sense, so conformal isomorphisms, and stuff like that, as well as the incredible Riemann theorem that tells us that any domain that is simply connected and has a boundary that contains 2 points, at least, is conformally isomorphic to a unit ball, basically. So we'll also prove that the theorem, the Riemann theorem. So more topology. And basically that is it. So those will be the main topics that we shall cover. And hopefully I will see you in the next video. Yay!